I hope everyone's doing well. I think working from home and doing online schooling, it makes me feel like I'm getting lazier every day. But let's go ahead and get started. Today's agenda is going to go over chapter 1 and practicing opening up Visual Studio. And I just wanted to make a point out that if you notice on the schedule, every time we start a new chapter, we will cover the entire lecture slides in that one time. So let's say when you go for on Monday, we will review chapter 1 and then we'll cover all of chapter 2 lecture slides all in one time. I'm putting this time right here at 6:30 to 8:50 because that's what the normal class was, from 6:30 to 8:50 if it was going to be on campus. So that's the time I'm going to be available if need be, but sometimes we might get close to that time, especially when chapters get a little bit more difficult and students have questions. So we might get closer to that time, but I'm hoping not to keep you to that time too much or go past it. So let's go ahead and go to chapter 1. Lecture slides chapter 1 is going to be at a more introduction level to computers before it goes into some computer lingo. At this chapter, please take it at a high level. When it talks about preprocessors and keywords, we'll learn more about those terminology as we move through the chapter or add it to, you get more experience with it. Let's go ahead and get started. And can someone message me to make sure that everyone can see my screen?
Yes.
Okay, thank you. Chapter 1, Introduction to Computers and Programming. What do we program? Computer is a programmable machine designed to follow instructions. If we do not program them, the computer is just a stupid electrical box. It doesn't know what to do. A programmer is a person who writes instructions to make the computer perform a task. Those can also be software engineering, cyber ninjas. You hear all kinds of terminologies, developers, engineers. They all pretty much come out the same thing. Computer system and hardware and software. There are five hardware component categories: the central processing unit, main memory, secondary memory, input devices, and output devices. We'll quickly go over them. Here's a picture. The central processing unit is comprised of the control unit. It retrieves and decodes program instructions, coordinate activities, and all parts of the computer. The arithmetic logic unit is a hardware optimized for high-speed numeric calculations. Hardware designed for true, false, and yes/no decision. This is all comprised in the CPU. And here's the picture. Main memory is volatile. Main memory is erased when your program terminates or a computer is turned off, also called random access memory. Organized as follows. The smallest piece of memory has 0 for false and 1 for true, and a byte is 8 consecutive bits. This is where all your programs are launched into RAM, where it gets processed, run, and everything like that. But once you stop your program, it goes out of RAM, you lose everything. Nothing is persistent. Main memory, each byte in memory is identified by a unique number known as an address. This is going to be very important, and it's going to come up again and again, especially in chapter 9. In this picture, it's nice. It shows that 72 is stored in memory location 23, but most of the time when you display memory addresses, it's in hexadecimal notation. But this is just the way memory is, because when you throw something into RAM, it's designated an address, and then that's where you dereference it. That's where it knows where to go. Secondary storage is non-volatile data retained when the program is running or when the computer is turned off. Everyone's familiar with secondary storage, hard drives, CDs, DVDs. It's where you persist the information. Input devices are devices that send information to the computer from outside. Many devices can provide input, keyboard, mouse, touchscreen, scanners, digital cameras, microphones, monitors, or even touchscreens, but it just gives input into the computer. Categories of software are designated into two different categories: system software, programs that manage the computer hardware, and the programs that run on them. Examples: operating system, utility programs, software. The other one is everyone's familiar with is application programs that provide service to the user. Word processor, games, Excel, all those applications that you use, not what manages the hardware. A program is a set of instructions that the computer follows to perform a task. We start with an algorithm, which is a set of well-defined steps. An algorithm is not necessarily instructions for the computer to follow. It could be written in English. Just all it is clear, defined steps on what a process should do, not instructions that the computer follow. For example, here's an algorithm for calculating gross pay. You can read these in steps yourself. But as you can see, if the first step, display a message on the screen, how many hours did you work, would not make sense if it's after step 4. When you define an algorithm, you're classifying clear defined steps in a particular order. Machine language, although the previous algorithm defines a step for calculating the gross pay, it is not ready to be executed. The computer only executes machine language instructions. Machine language instructions are binary numbers such as ones and zeros. Rather than writing programs in machine language, programmers use programming languages. There are low-level and high-level languages. Low-level used are for communication with often hardware directly, often written in machine code, or sometimes even one step above that is assembly language that is written at very low level. And what we're going to use, C++, is known as a higher level, closer to human language that's compiled into machine code. Here's some examples of high-level languages. Please ignore this one. This is one of the world's languages that there are. I know this was one of my first languages, and I did not like it. In order for C++ source code to go from high level to executable, it goes through these steps. You create a file containing the program with a text editor, run the preprocessor to convert source file directives to source code program statements, run the compiler to convert source programs into machine instructions, and run the linker. I want you to be very familiar with this flow. All the stuff that happens behind the scenes you will not see when you hit the compile. When you hit compile code, all this goes on behind the scenes. Here's an example of a source file, the traditional hello world that everyone writes to start up a programming class. When you click the build, which we'll do in lab today, the preprocessor will run. That gives you the modified source code. Then it executes the next compiler, which gives you the object code. The object code is machine code minus all the runtime libraries. The linker takes the object code and links it to the runtime code, runtime libraries, to give you the executable. Be familiar with this flow. An IDE is an integrated development environment. Combine all tools needed to write, compile, and debug a program into a single software. You might be familiar with Borland's Visual Studio. If you're familiar with Java, you might be familiar with Eclipse or IntelliJ. Those are also an IDE, integrated development environments that help you create your application, your software. It allows you to compile it, build it, and run it, and debug it, and even write it. Here's an example of an IDE that we'll see in Visual Studio. It makes it very easy to build, run, and debug your code. And also, you can see it changes. You can have this augment different colors for comments, keywords, and so forth. It will help you write your code. What is the program made of? It's keywords, programmer-defined identifiers, operators, punctuation, and syntax. Here's a program that gave us the algorithm earlier on. If you look at this, you'll be able to see at a high level what it's doing. Here's your variables that you created. You're displaying something out, you're reading it in, you're displaying it out, you're reading it in, you're doing some kind of calculation, and you display it. You could see this at a high level without knowing all the syntax of the language. Keywords is also known as reserved words, have special meaning, in C++. Cannot be used for any other purpose. Keywords in this program are using, namespace, int, double, and return. This is saying, hey, we're using the namespace. I call it standard STD. These are int, double. These are keywords giving what kind of data types, and return. Here's some of the keywords that they can only be used for the purpose that they are designated for. That is why they're called key or reserved words. Programmer-defined identifiers are names made up by the programmer, no part of the C++ language. These are variables that you create, and we'll learn how to create them. Hours, rate, and pay. These hours, rate, and pay, remember earlier on, will have addresses to them because they're going to be launched into memory. Operators are used to perform operations on them. Many types of operators are arithmetic: addition, subtraction, multiplication. This is also going to have dual purpose when you go into later chapters. The division, and then the assignment. This is the assignment, not the equality check, so be very careful. Oops. Some operators in program 1, we call this redirection operators, assignment, and the multiplication. As you see these here, they are called indirection operators because I can see it's going to take how many hours did you work and display them out. And this is going to be seen in, so you can always see which direction it's going for the string. Characters that make the end of the statements or that separate items in a list are comma and semicolon. In the list, if they're all the same data type, you can do common notation right here. But each statement in C++ must end with a semicolon. These with the / right here are not statements, they're comments, and we'll discuss those later on. The rules of programmer that must be followed within writing a program. Control the use of keywords, operators, defined symbols, and punctuation. If you break these rules, you break the syntax, and a lot of that will be caught by the compiler. A variable is a name, a storage-based location in memory, the computer's memory for holding a piece of data. Remember these variables: hours, rate, and pay. Those are programmer-defined variables, but when you put them in RAM, they are assigned an address. Each time the program is launched, it's going to get a different address. But we will reference them by using our variable names, not the address location. To create a variable, which we'll get more familiar with in Chapter 2, you must define it like this: the data type and the variable name. There are many different types of data which we'll learn about in this course. A variable holds a specific type of data. Yes, string, int, a floating number. Floating numbers are those containing a decimal. Characters, single byte, and a string, and structures. There are other variable types that we'll discuss as we move throughout this course. Once again, the variable definitions are double, hours, and rate. The double specifies that it can handle decimal places. Three steps that a program typically does. Know it. It's input, process, and displays. For example, in this case, it gathers input, it gathers the hours worked, it processes the input, calculates the pay rate, and then displays the output. This is an idea of what the programming process should look like. Clearly define what the program does. Visualize. You can use tools, hierarchies, charts, flowcharts, and pseudocode to create a model. We will not use hierarchy charts in this core class, but we will use flowcharts. Click the model for logical errors, type the code and save it and compile it. Repeat the steps. This is where students are going to spend most of their time, is resolving errors. There are two paradigms when you write code. In this course, we're going to stick with the first one, the procedure programming, which focuses on the process. Procedure functions are written to process data. The other one is the next semester, 1437, object-oriented programming. Focuses on objects which contain data and the means to manipulate the data. Message sent to the object to perform operations. And what that's saying is, since it's tough, it's more on how the data is represented. Let me see if I could do this. Unlike where we would see this before when you do double rate, you would have a class or an object called double. And inside there, you would have everything encapsulated as for the float value, attributes of, let me just put attributes of this file, of this object, and the functions it can do. So in object-oriented, you're doing more of data encapsulation, data modeling, more than procedure code, which is do this, do this, do this, and so forth. Oops, let me go back. And I believe that is all in this chapter. Any questions? One thing I don't like about doing it online like this, I can't see if you have any questions, and it's hard. I can't scribble on the board easily back and forth. But for at this point, do you have any questions or anything else that we covered?
No.
What did you call the
Really?
what did you call the equal, I mean, like the double arrows? Again, you went kind of quick on that one.
Okay. Someone raised their hands. Sometime when I was sharing the screen, I couldn't see people raise hands if you have questions. So in the future, if you have questions, just speak up because I cannot see it. You're talking about this?
Yes.
These are the direction operators. And we'll see that when you write code, like when you write cin to this to be rate, you're going to be reading in something from the keyboard, and it's going to be read into rate to this variable. So it's kind of like direction. Think of what you want it to go. Whatever I want to read in, I want to store here. That's why I'm pointing in that direction. Unlike cout, this is going to go display to the monitor. And we'll see that in a moment when we do our first lab.
Okay.
Does that clarify?
Yeah, yes.
Okay. Any other one have questions?
Do you feel like there should be something specifically we're looking for once we start to actually write code and we're gonna, that we're gonna have a bunch of errors? Like, how do you think we go about like some ways to just be aware of mistakes you're making, I guess?
Well, the normal steps that I help students write when you do the first program, and we'll build upon it, especially when you get past chapter 3, when you use the same program. A lot of students have a difficult time reading the problem and translate it to an algorithm and into code. So what I do is I kind of create a flow chart. Let me see, draw IO. And so sometimes I'll do like this to help students out title. But before I go to that part, we start defining what the program should do, what I know, and what I need to know. From here, we would go from here, and then we'll create a flowchart saying, title, what do I need? And start breaking it apart that way. This way, if you have this flowchart, as we'll do with this procedure code, this will help you. Hopefully, I deal with this part right here, and the flowchart will help you realize where some of your logic errors are coming. But when it comes to the syntax one, you're just going to have to learn the syntax through trial and error, if that makes sense. The flowchart will help you with the logic thing, saying, I need to do this first, I need to do this first, I need to do this first. But when it comes to the syntax, you just have to know the language. Did that help answer your question? So doing this transition from what I need to know or what I need to do to a flow chart will help you give the algorithm to write your code.
Yeah, that's helpful.
Yes. Normally when it was in the classroom, we would write this flowchart on the board together, and then the students would come up to the instructor station and write the code. I only write the code one time, and every time I'm up at the instructor station, it was in the classroom. Other times, it was always students. I would call on students to say, I need to grab the number of seats sold. Who's going to come up and write it? And so I always made my class interactive. I don't know if I could do the same thing here, if I can constantly make students take over my screen and so forth, but maybe I can call on people and say, what do you want me to write? Any other questions or concerns? No? If not, you can ask questions later on. And please, this was my first online lecture like this, since I couldn't see any people raising their hands. If you have questions during the lecture, please speak up. I guess that's what we should do going forward, because I can't see you in like a classroom where a student can raise their hand. Okay?
Okay.
Thank you. Let's start with first practicing Visual Studio, at least get you familiar with it. I hope everyone had access to get to the iCloud or download Visual Studio. You can use your own compiler at home if you have one of your preference. But once again, make sure it runs on the Visual Studio here, because this is what I'm going to run. So let's get started. I'm going to launch Visual Studio. Visual Studio 2019. And I'm going to catch some key traps with students doing this. And all this is documented in one of the documents online on Blackboard. Right here, when Visual Studio opened for the first time, or if this is on the cloud that they constantly reset everything, this might come up over and over again. You do not need an account. You can say not now, maybe later. You could choose your preference, and you can later on change it if you like. I use the dark. And please be cautious that Visual Studio is slow. So the days that we do labs, I might go ahead and get all this set up. I wanted you to see it. What we're going to do is we're going to create a new project. We're not going to check anything out from a repo or anything, so continue with new project. We're going to click on this one. Make sure you click on empty project, C++. This course is going to always be on the console. It's not going to do anything with graphics. So hit next. I recommend that you change this to be the desktop. I don't know if we have access to this. I know in the classroom sometimes we have permission problems. So I'm always going to change this to be on the desktop so I can have easy access to it. I am going to change this to InLab. I'm going to hit create. Notice I call this InLab. Do not call it the same file as your source file. You'll get confused on when you submit it. The IDE will come up. In the Solution Explorer right here, you're going to left click and highlight it and right click and say Add New Item. You want to choose C++ file, not the class, not the header file, but this C++ file. I'm going to name this temporarily to be my source file. Keep the extension CPP on it for C++. When you get your labs, this part right here is what you're going to change to be gradebook or whatever I tell you to name it. This is what you're going to name, not your project. Don't get confused between your project and your source file. So I'm going to click on Add. And then as you can see right here, I am already in my source lab and I can start writing code. Any questions so far on how I got here? So I heard someone click. All is good, thank you. Just speak up, say all is good. Sometimes I don't have to go back and forth, but thank you. Go back here. What I'm going to type is not everything that we did on that one practice lab where we did calculate hours. I'm just going to create something simple to show you to compile, build, and run. You do not need to be familiar with all the preprocessor, all the using namespace, and so forth. You will get familiar with that as we go through each chapter. It's going to be explained. But let's just get used to the ground running on practicing. So I'm going to use this include, which is anything that you see with the pound include, that is a preprocessor, especially if it has these angle ones right here, IOStream. You can use IOStream a lot. Oh, but first, you do your labs. Let's get prepared the way you want to turn in your labs. Always put your name on it so I know when I'm looking at your code. This is a single line comment. We'll go into that as we move along the chapter, but what the comments mean is, compiler, please ignore this line. You use it for documented purposes. Here's the preprocessor directive. I'm going to say also using namespace std. From here, you start with your main function right here. This is, you never call this. This is when you run your program. This is what's going to start looking for it when it gets run, and it's going to start executing. For simplicity, all I am going to do is use the cout command, which is just saying, hey, send this to standard out. Standard out is your monitor. So the typical way we say for the first program is usually hello world. And notice I end with a semicolon. To build and compile your code, you can do two ways. You can do build and build solution. This window will come up, and it'll say, my CC says building, and it'll be success.
Is there like a built-in boilerplate, or are we able to like create our own boilerplate for kind of these standard items like that?
Yeah, if you want to do that, you're fine to do that. For a beginning course, for practice, I would always want you to type it just to get the practice with it. But yes, you can create your boilerplate. You can create a notepad and just copy and paste this in. Yes, whatever you feel comfortable with. However, in practicality, I would recommend you not to do that for the first couple programs, just to get the practice of getting it set up and then making sure you know some of the layout of your program to get practice with it at first. Once you get better, more power to you.
So what character do you have before the int main? I'm just trying to
This
copy
right
you as you go on my second monitor. Yeah, I'm just trying to copy it.
Right here. Oh, this right before int main, you talk about this little minus sign.
Yeah.
That's part of the IDE. It allows you to close things up.
Okay, gotcha. I'm just trying to copy you to kind of see what I can do here while you're doing that.
Do I need to make this writing a little bigger for you, or is it good for the class?
Make it bigger.
Can I make bigger, please?
Yeah, I can make it a little bit bigger.
I can do that. Is that better or bigger? More?
Like if you expand the window.
Yeah, make it full screen.
Let me see. I don't know. Let's see. Well, this is in the browser, so let me see. That's probably worse? Let me see. Is that better?
No, I forgot what it's called. The expand. We're seeing your screen. We're not seeing
Make the browser
browser.
bigger.
So you make the browser bigger, it covers the screen.
It's good for me.
I don't know what it looks like, so let me see. Okay. Because I got a big widescreen monitor, so I don't know if that bothers the layout of it or not. Is that better or good? Okay.
Yeah, it's better.
Okay, thank you. As you can see, I didn't have any errors, but if I do, let's say if I remove the semicolon, and I do, as you can see, it gives me this red squiggly line, even though it's not on the line of the error. But when I do build again, build solution, the error messages will show up here. And trust me, you'll get familiar with seeing these errors when you first start practicing code. You can save it. If you don't build, you can also go to right here, start without debugging. Debugging allows you to put breakpoints in and pause your code. We will see more of that later on, but if you use debugging, it takes more memory and it's a little bit slower because it has load up a lot more functionality. But right now you can do start without debugging. And as you can see, it comes up here. This is part out by the operating system, but you can see where it says hello world. And then you can simply press any key to close. Any questions?
Can you explain what exactly is happening with the include IOStream and using namespace?
Include IO allows you to handle cout and cin. Think of it as the system library that makes you understand what cin and cout does. It is in use conjunction because it's part of the standard library. Because if I don't oh, I hate that keeps bouncing around. If I don't have this, this is going to error out because if you're using like Xcode or other IDEs or seeing the code, they would sometimes write it like this. Using names, IOStream is a preprocessor directive that allows you to move streams around, like using C in and C out to say, send this stream of bytes, let's say, to send C out. The program doesn't know what it does, but the operating system says, hey, use this library to do this functionality. And allows this, if I don't have this using namespace throughout global scope, I would need to put this in. So if you're familiar with any XML, AML, and so forth, you might be familiar with namespace. So this is saying, hey, using this namespace, std, this function, this namespace throughout my code. If I don't have that, if I use namespace, if I have namespace up here, I don't need std right here. But if I don't, and I need a scope resolution operator, because cout is probably defined in other libraries. So you have to dictate which one you want to use. You get more familiar with these preprocessor directives as we add more and functionality that they use. They allow you to understand the functionality of C in and C out, how the operating system and how it works behind the scenes, if that makes sense.
Okay, so are the I mean line 3 and 4, so they're linked together, or they're
No.
operated separately?
They're operating separately. This IOStream is used to tell C in and C out how to display things to screens or read in variables. However, C out can be used in other libraries. It can be defined in other preprocessor directives. So without this, as you see, when I comment out that, it's going to give you an error message. Identifier cout is undefined because there could be multiple cout ones. It's not designated to know which one's which because cout could be defined somewhere else too. So that's why you use this global using namespace to say, I want to use the version std, the standard one.
Oh, okay, I get it. Okay, thank you.
Good question.
Okay, I have a question that might seem really dumb, but how do you figure out like how I see you're putting like 2 spaces between some lines and 1 space between others. I don't really know if it'll give you an error for only doing 1 space or how
Doesn't
spacing
matter.
works, line spacing.
The compiler ignores white space. So I could do all this and it's still going to do the same. Oops.
Okay, but what about like the first line in between like IOStream? So you can put space doesn't even matter with a compiler at all, or with this one
Are you talking about like this?
Yeah, so can you all put it like one line after another and it won't do anything?
Talking about like this?
I mean, I'm just wondering how line spacing works, like if it'll throw you any errors or any
No,
syntax
no,
errors.
as long as you have the syntax in, because I can put another cout like right here. White space is for you.
Okay, because it just looks clustered like that, I guess, so that's why you're putting the spaces.
Exactly, because as we get into more code, it's going to be a lot clearer for you to understand and debug when you see these indents. So when you have these spaces and so forth, let's say later on, we say, if true, when you start talking flow, and you see these indents that we have, code to execute, and then else. It's a lot easier to see, oops, when you have these indents to better for clarity. Does that make sense?
Yeah, that makes sense. I see it already. I mean, I don't understand exactly what it is, but I see how it looks a lot clearer. Looks like it'd be much easier to understand.
It is.
Split it up, yeah.
Yeah, because you don't, especially when you're going to do in the real workforce, or someone look over you, you always want it to be clean to what you write. right, anyone else? All right, let's go back to the code. We saw how it executed, so let me just save this. And you will get very familiar with how to write it as we get more complex in labs in. As you can see, here's our project folder right here. In lab, and in lab right here. As you can see, these are the in labs right here. And you have to go 2 nested deep the way Visual Studio and the way I have it set up is. And here is my source CPP file. This is the file that you want to save. I keep on hearing beeps. Okay, they're just helping one each other out. So this right here is your source file. This is what you are going to submit. This is what you want to save off. Because you can always create an empty project, and if you want to add in a project back, you are going to, instead of going to my source files, instead you're going to go to add, and instead of new item, you're going to say existing item and redirect it to where you want it from. Because if you go to Visual Studio or CPP file and you just double click and Visual Studio is installed on your computer, by default, sometimes it automatically opens up in Visual Studio, but you will not have any of these functionalities of build. You would just be able to see the file, but you won't be able to execute it. Any other questions? Someone had questions? Someone said ask the instructor.
I think they're wanting to know how you got the box and the IDE for minimizing and expanding the code.
What do you mean expanding the code?
So you know your main method that you have there?
Right?
So I think they want to know how the IDE set up the expansion, the minimize and maximize for the main method. And that's just part of the IDE. My question for them are, do you have the curly brackets up? Because that's part of what it looks like when it's the curly braces.
When you normally have opening, closing parentheses, usually something, it could be a setting in Visual Studio that automatically adds these so you can close them and minimize them, because when I create new functions, see, it automatically starts adding them up. A lot of IDEs have this so you can close that functionality.
I think he's asking how come it's not showing up on his screen. In the thing.
Do you have open close parentheses correctly bounded? Because that's what they usually spun by. If not, we can take this offline and you can share your screen later on, and so I can see it. With also on Blackboard right here, I have given you the source code from the book. So you can easily download it and unzip it and create a project and copy and paste the code in so you can start practicing with it. So you do not have to write all the code down. So you can create a project, copy and paste it in there and practice with it. But for right now, go ahead.
What is that source code for again?
This source code is for all the code in the book. Like the practice one, so when you download right here, source code, you can see it from all the chapters right here. So
you can just open it up into like Microsoft Studio and try to play around with it?
Exactly. So you don't have to type it. You create an empty project and then you just copy and paste it in there.
And does it have like built-in mistakes that you're supposed to fix, or?
No. These are just the codes from the book.
Okay. So those are completed. You just want to look at them.
So if you want to, let's say we start doing with functions, instead of writing and you want to practice with it, you can bring this code in and practice creating your own function inside. Because this is working, you can manipulate and play with. It's like, oh, what about if I change the function name here, or I don't have a prototype? You can start practicing with it.
So you can just play around with it essentially. So it's just like good practice, so like something you should do in your free time 100%.
Very much. So very much you should practice and set alone time to practice with it. A lot of students do not do that, and they wind up spending a lot of hours on the labs that I assign. The labs that I assign are going to be challenging. So to get a lot of practice up front and understand when you do the in labs will help you, especially when it gets later on this course. If you can get through chapters 4, 5, and 6, 3, 4, 5, and 6, then you have it made, because 4, 5, and 6 are the confusing ones. 4 is logic, 5 is looping, and then 6 is functions. Those are the tough chapters. If you can understand those logic ones, 4, 5, and 6, the course is made. Because a lot of students get frustrated with those chapters, and then they do not ask questions, and then and each chapter kind of builds on top, so they kind of get back. So, any other questions for what we did today? I don't want to put too much onto you in the first week of classes, but I just want you to get familiar with being able to open up a compiler and practice with it. Because when you start doing it next time, when you do chapter 2, we're going to open up and add more to it. In chapter 2, we do cout. I think chapter 2 is more of the data types. The data types that we're going to talk about are the ones that they say is double, rate, pay. These determine the data type, and we're going to talk about that in chapter 2. There's also ints and so forth that we're going to talk about as well. Each chapter adds more and more. But I just want for this class just to get practice right now and open up Visual Studio, getting a C++ file in place, and practice writing your code. So you have a template of where to go and to practice. Any questions or concerns? No? Well, it's going to cover up a next class period on Monday, the 31st, is we're going to have a review for chapter 1 and go strictly into chapter 2. We'll cover the entire chapter, and then that's it. The following after chapter 2 is then we would have the review of chapter 2, and we'll do a practice lab. Every time we complete a chapter, we will do an in-lab to help emphasize everything that we talked about. And then also, if you have any other questions, feel free to bring them up. We can open up an IDE, we can practice, and so forth. And you can say, well, what about in this scenario? What about if I do this? And we can help. For your in-labs for home, if you get stuck and it's in the classroom, we can open up a session together and you can share your screen with me and I can help you walk you through it. But do you think anyone from this class will have any problem getting to this point right here? Let me go back. All good? Okay. If you are all good, please practice. I'll see you again on Monday. I'll stop the recording.